is vocabulary for polynomial functions. So after this lesson, you should be able to identify if an expression is a polynomial, identify the degree, name it using number of terms and degree, write the polynomial in standard form, talk about the end behaviors, and identify maximum number of turns for the graph. So, well, before we even get started, we need to talk about some vocab. So a monomial is basically a real number, a variable, or the product of a real number and a variable. And maybe it could be more than one variable, right? So, but no variables in the denominator. So like 3x squared y, that's an example of a monomial, right? A polynomial is either a monomial or the sum of monomials. So we could have said, oh, plus 3x, right? So we have the sum of two, right? Or we could have the difference. We could have many terms, right? But no variable in the denominator. And that's kind of like a key thing, right? You're not going to be a polynomial if you have a variable in the denominator. So no variable in the denominator. Okay, standard form is when we are writing them in the terms in descending order from the highest degree to the lowest degree. Now, when I'm looking just at a monomial, this degree is 3 because we have 2 plus 1, that's 3, and this degree is 1 because that only has 1. So this would be a highest degree for x, right? So you either going to put things in descending order related to x or in descending order related to y. If we were just looking at x, the degree of just the x is 2 here. So this still would go in front. Okay. So here's some vocab for if we have one term, it's a monomial, 2 terms binomial, 3 terms trinomial, 4 terms polynomial, 4 terms, etc., etc. 5 terms is the same, right? If something has degree 1, it would be linear, degree 2, quadratic, degree 3, cubic, degree 4, quartic, degree 5, quintic, and there's more, but these are the ones that we're going to highlight. Okay, so if we're talking about degree, we're going to be, for a monomial, we just add up all the exponents. For a polynomial, we're going to use the degree of the monomial with the highest degree, okay? So let's look at the degree of these polynomials. So obviously, we have 3 terms in A. We have this term that has degree 1, this term that has degree 2, and this term that has degree 0. So the highest degree, because this is a polynomial, is going to be 2. So the degree of this one is 2. For the next one, we have 2 terms. We have this term, which has degree 3, and this term that has degree 1. For this one, this term has the highest degree, and the degree is 3. So the next one we have 2, 1, 5, 3. Okay, so the highest degree here is 5. So that's the degree of the whole entire polynomial. Okay. For example 2, we're looking to put things in standard form, right? And so when we do standard form, we go from the highest degree to the lowest degree in descending order. And then we're going to classify them using the number of terms and degree. So let's start off with this one. So this degree is 1, this is 2, and this is 0. So the highest degree would be 9x squared. Then comes 3x, and then minus 5. So this is standard form. And we have the highest degree is 2. So that means we're going to have a quadratic. So when we name this, we're going to have a 3 terms trinomial, a quadratic trinomial. Quadratic trinomial. Sorry, that's like squishy town. Okay, next one. So we look here and we have a degree 3, degree 1, degree 3. Oh, dang, we have 2 with the same degree, which means we can combine those two like terms. So let's even get this a little bit nicer. So these are like terms. So we're going to have 3x cubed plus 7x. So the degree here is 3, the degree here is 1, so definitely our degree is 3. So this is in standard form right here. Our degree is 3, so we go back up here and we have 2 terms. So we'll be a binomial that is a cubic. So we're going to do a cubic binomial. Okay, let's look at the next one. Wow, we got a lot of terms here, right? So let's first combine like terms. We see these two are like terms, and then put it in descending order, which is standard form. So x to the 4th minus 3x squared, and then our like terms will have negative x plus 10. So we have a polynomial that is of 4 terms, right? Polynomial of 4 terms, and our degree is 4, right? Our degree is 4. So we're going to have a quartic polynomial of 4 terms. Okay. All right. So when we talk about end behavior, basically we're talking about what happens at the end of a graph. So like if I was doing this graph, the end behavior here is going down and the end behavior here is going up. Okay, so we need to organize this related to even and odd, and then that's our degree. Like odd, like a line, right? Line has degree 1, and even like a parabola or a quadratic. Okay, so now what we're going to do is we're going to take a look at the leading coefficient. So if our odd degree is like a line, if it has a positive leading coefficient, it's like a positive slope. So a positive slope would go like this, which means that it would start going down and then it would end going up. For negative, it would be like this, which means it's on the left going to be going up and on the right going to be going down. Okay. Even is like a parabola. And we know that if a parabola has a positive leading coefficient, that it's going to be looking like this. So that would be on the left, it would be going up, and on the right, it's going to be going up. And likewise, if a parabola has a negative leading coefficient, the number in front of the squared term, it's going to be going down on the left and down on the right. So basically, even goes the same direction and odd goes the opposite direction. Okay? Okay, so let's look at these to decide the end behaviors. Okay, so the degree of this one is 8. So we know this is even. Oh, dang it. So we know this is even. And the leading coefficient is negative 3. So we're going to be going even, negative, which means my end behavior for even negative is down on the left and down on the right. Okay, the next one we have 6 is the degree, and so the coefficient for that is going to be 9. So we have even because of the 6, and then positive because the 9 is positive. So this guy is going to be going up and up. Up on the left, up on the right. The next one has degree 3 and leading coefficient negative 8. So this is going to be odd and negative. So odd negative is right here, and that's going to be up on the right, or on the left, sorry, and then down on the right. Okay. All right, so hopefully that helps. And then the last thing we're going to talk about is the maximum number of turning points. When we're looking for turning points, And this, we can see that this changed direction here and it changed direction here. So that would be 2 turning points. If I want to know the maximum number of turning points, I'm going to take my degree minus 1. So for this one, the degree is 6. So 6 minus 1 is going to be 5. So at most 5 turning points for this one. And that's really messy. I'm just going to rewrite that because I really did not like the way I wrote that. So at most 5 turning points. Okay, the next one I'm going to look at is the next one has degree 4. So we would go 4 minus 1, and this one would have at most 3 turning points. Okay. All right, guys, I hope that helps. Take care.